So the topic for today is solving equations in one variable. And first thing we're going to do is talk about some definitions. So these are some words that I may use when I'm explaining things to you, and I want you to know what they mean. First of all, an equation in one variable is an equation that has one variable in it. So, for example, 2x minus 1 equals 7, that has one variable in it, an x. This equation, 2x equals x plus 8, is also an equation in one variable because it only has one variable in it, x. It's in there twice, but it still only has the one variable, x. Alright, that's an equation in one variable. If I have an equation that has an x and a y in it, that's an equation in two variables. Alright? The solution is the value for that variable. So what number does that variable represent? Alright, that's its solution. A solution set is the set of values for the variable. Sometimes when we solve an equation, and we will get to this, sometimes we are going to have multiple answers. In that case, all of the different answers or all of the different solutions are put in a solution set. A root is a word this book uses quite a bit. A root is a solution. So if you are reading directions in the book and the book says find the roots of the equation, that means solve the equation. Tell me what the solution is. Our action word for today is solve. And what this means, find the value for the variable. What does x equal? Alright? When you answer, you're going to write x equals, and you're going to put whatever number that is. Alright? So, how do we do this? We are going to use something called the golden rule of algebra, which you remember from Algebra 1. Do unto one side of the equation what you do unto the other. So in other words, you can add, subtract, multiply, or divide, but you have to do the same thing on both sides of the equation. As long as you do that, you will get an equivalent equation. So in other words, an equation that has the same solution. Alright? So ultimately, how do we solve an equation? We want to get the variable by itself on the left-hand side of the equation, so your solution will look like x equals, and then you're going to write what number it equals. How do I get x? By itself on the left side. Do any of the following. You can simplify a side of the equation. Usually, if you're going to simplify, there's a couple things you can do. You can combine like terms, or you can distribute. Those are ways that you can simplify. Additionally, you can add or subtract the same number on both sides of the equation. Or you can multiply or divide both sides of the equation by the same number, but not 0. Don't multiply both sides by 0. Don't divide both sides by 0. That will just blow your entire equation away. Don't do that. Alright, let's go to the next page and go through some examples. Alright, here's an example. In this particular situation, we have the variable, which is t, on both sides of the equation. One of your goals is to get all of your variables on the same side. Alright? In this case, the way we're going to do that is through adding or subtracting. Specifically, we are going to subtract 5t on both sides of the equation. What we then have is 8t minus 5t leaves us 3t plus 17 equals, I carry down my equal sign. The 5t and the minus 5t cancel each other out, so it's gone. So this equals 35. We want our t's to be alone on this side of the equation. From here, you've got something that's called a two-step equation. Your two steps are to add or subtract first, then do your division. So first thing, subtract 17 on both sides. So I have 3t, the plus 17 minus 17 cancels itself out to 0. 35 minus 17, I believe, is 18. Your last step, divide both sides by 3. That gives me t equals 6. Now, in the box, there is a hint. Never get a wrong answer. Anytime you are solving an equation, you can check your answer by plugging it back into the original equation. And what you want to do is see if you get the same thing on both sides. If you do, then you've got the right answer. If what you get on the left is different than what you have on the right, it is the wrong answer. So if we were to do this, let me use my calculator here. On the left-hand side, 8 times 6, 48, plus 17 gives us 65. On the right-hand side, 5 times 6 is 30, plus 35 is 65. We did get the same answer on both sides. So that proves this is the correct solution. All right? You can always do this. Now, the benefit of the homework assignment that I gave you is that you don't have to, because I gave you the solutions so you can check them and save some time. But when you take a test, this is a fabulous tool to use, because you may be able to catch your mistake before turning your test in. All right, next one. If you notice, I have a lot of stuff here. Before I start adding and subtracting on both sides, I'm going to combine my like terms so that I can make this simpler. So here's what I've got. I've got a negative 3z, but I have a 5 and a negative 18. So this is, when I combine like terms, negative 3z minus 13. Over here, I've got z and 8z. This gives me 9z minus 1. Now, I want all my z's on one side. Something you may find, which I find to be true, is I'd rather if my z's come out to be positive. It saves me having to divide by a negative later on. So what I'm going to choose to do is add 3z to both sides. You can subtract 9z on both sides. Both steps would be correct. So we're not all necessarily going to do these the same way. We may take different steps. Here, my z's cancel, and I have negative 13 equals 12z minus 1. I want to get my z's by themselves, so add 1 on both sides. And what that's going to give me is negative 12 equals 12z. My last step here, divide both sides by 12. And what this gives me, I have something that looks like this. Negative 1 equals z. You will find that as I'm doing problems, I am never going to write it this way. I could look at this, and I'm going to switch them around so the z is first. Z equals negative 1. All right? Next one. I am given something that is a decimal. If you are given a decimal, you can proceed using decimals. If you are given any other integers or fractions, you must proceed with fractions. The only time you can proceed with a decimal is if you are given a decimal. So, in this instance, my first step here is actually, I would like to distribute. All right? So when I distribute, I have negative 7.5x plus, because I have negative times negative, 7.5 times 3 gives me 22.5 equals negative 30. What would be my next step? Subtract 22.5. Before you do the division, do the adding or subtracting. So minus 22.5 on both sides This will give me negative 7.5x, the 22.5's cancel, equals negative 52.5. My last step here is to divide both sides by negative 7.5. I have negative divided by negative, that's going to give me a positive answer. And here's what I have. I have x equals 7. All right, sometimes you'll find that there's a lot to do in the problems. All right, there's a lot to do. If you're confused about where to start, think of this. You are undoing an equation. So look to do things in the backwards order of operations. All right? So in other words, first thing you want to look for is, can you add or subtract something? Then look at whether you or not you can multiply and divide. Whenever I see this, usually what I like to do is distribute. Then I can do my adding and subtracting, and then my multiplying and dividing. So I'm going to distribute. And I have 10x minus 45 equals 7x minus 60. What would be a good next step? Subtract 7x. Get all your x's together. All right, so here's what I've got. 3x minus 45 equals negative 60. What's my first step here? Add 45. And I've got the 45's canceling, so it leaves me with 3x equals negative 15. Divide both sides by 3. X equals negative 5. All right, let's go to the next page. These are a little bit more complex. All right, first of all, right here, what would you think we should do first? Distribute. Really, there's a negative 1 here. Distribute that. All right? So this will give me 10y minus 5y minus 8 equals 42. What's my next step? Combine my like terms. They're already on the same side. Just combine them. 10y minus 5y gives me 5y. My next step? Add 8. Look to add or subtract before you multiply or divide. So here's what I've got. The 8's cancel. I've got 5y equals 50. Divide both sides by 5. This gives us y equals 10. All right, this is tricky. Yes, absolutely. I'm glad somebody recognized this. Here's what we've got to do. We've got to FOIL this. All right? So first of all, the first y times y is y squared. The outers, y times negative 1 is minus 1y. The inners, negative 5 times y is minus 5y. The last, negative 5 times negative 1 is plus 5. Then continue writing the rest of the problem. This just made life easier. What do we do now? Combine like terms. I've got a y squared and a minus y squared. That cancels to 0. Bye-bye. All right? Negative y and a negative 5y give me negative 6y. Then subtract 5. So I've got the 5's canceling. And I have negative 6y equals a negative 18. Divide both sides by negative 6, and I get y equals 3. Take a look at C. What would you do first here? Distribute. So this would give me 2t minus 6 minus 17 equals 13 minus 3t minus 6. Because remember, when I'm distributing the 3, I'm really distributing a negative 3. So you have to take negative 3 times positive 2 here gives you a negative 6. That will be one of the biggest mistakes in a problem such as this. So don't do that to yourself. From here, what would you do? Combine like terms. So negative 6 and negative 17 is negative 23. So 2t minus 23. This is negative 3t, and then I 13 minus 6 is going to give me plus 7. What would you do next? Add 3t. Get all those t's on one side. Now I have 5t minus 23 equals, the 3 t's cancel, and I have 7. What's my next step? Add 23. The 23's cancel, and I've got 5t equals 30. Last step, divide both sides by 5. T equals 6.